Hey everybody, this is Mr. Mazzoro again, and today we're going to start our discussion of fish. You've made it through 4 units in marine science, and finally, after those 4 units, we're finally going to start talking about fish. Animals that live in the pelagic ocean, or the open ocean. That's what pelagic means. We've already talked about benthic animals, animals that live on the bottom of the ocean, whether that be the bottom of the shallow ocean or bottom of the deep ocean. But now we're going to talk about the stuff that swims through the ocean. And the first lesson is going to be pretty basic. It's just going to talk about the 5 zones of the pelagic ocean. It wouldn't be marine science if we didn't describe zones before we actually started talking about organisms that live inside of them. And then we're going to talk about the general adaptations that all organisms in the ocean have to have in order to live in those zones. So let's begin. Again, the pelagic ocean means the open ocean. Benthic, anything near the ocean bottom. Pelagic, anything that's in the open ocean. And the ocean, one more time, is a really, really large place. And as a result, just talking about the pelagic ocean, just because it's all underwater, just because it's all not near land, doesn't mean you're really talking about a homogeneous thing. There are many different areas with many different characteristics, and as a result, organisms need to be differently adapted to live in each one of those areas and each one of those characteristics. So the pelagic ocean can be divided into 5 zones or 2 zones. And depending on what adaptations you're talking about, it's going to be necessary to divide the pelagic ocean into those 5 zones or those 2 zones. So first, the 5 zones of the pelagic ocean, and then kind of the 2 general runs that we'll focus most of the discussion on. First zone of the pelagic ocean, the one all the way up on top, is known as the epipelagic. What makes it the epipelagic, what makes that zone a zone, is that it's the only zone with enough light for photosynthesis. Very, very important and a little bit misleading in this diagram. I understand that there are no fish in this area. There are no pictures of fish, but that does not mean there are no fish on the surface of the ocean. There are more fish up here than anywhere else in the ocean. In fact, this diagram does a pretty good job of demonstrating the general types of fish you find in each region, but it does a horrible job representing the numbers of fish you find in the region. So there's no real room to draw all the fish up here, but suffice to say that about 98% of the life that you find in the ocean is in this top 2% of it, the epipelagic. The reason why there's so much life in that part of the ocean is because that's the only part of the ocean with enough light for photosynthesis. Photosynthesis means primary production. Primary production means lots of food. Lots of food means lots of animals. If you get much below the epipelagic, you enter an area known as the mesopelagic. The other name for the mesopelagic is the twilight zone. The reason it's called that is because that's the area where the light is dim. There's still light, but it's dim. And it represents, or it's representative of the light that you see at twilight, the time between when the sun sets and the moon rises. That's twilight. When it's not quite night, it's not quite day, you have that sort of ambient light. That's the type of light that you see in the mesopelagic zone. Epipelagic, there's enough light for photosynthesis. Mesopelagic, there's light still, but there's not enough light for photosynthesis. When you get below the mesopelagic zone, you enter 2 zones, the bathypelagic and abyssopelagic zone. The bathypelagic zone is actually more shallow than the abyssopelagic zone. Both these zones are completely dark all the time. No organisms that live inside of them that don't go to the surface will ever see a shred of daylight. The big difference between them is the depth. Bathypelagic is a little more shallow than the abyssopelagic. The real reason why it's not considered one zone is because if we consider this whole area one zone, you'd basically be saying that about 80% of the ocean is one unified zone, which isn't true. So scientists divide it into 2 regions, the bathypelagic and the abyssopelagic. The bathy being more shallow than the abysso, and that's really the only difference between them. They're both completely dark. Last but not least, you have the hadopelagic zone. The hadopelagic zone are zones in ocean trenches. Anywhere where you're in an ocean trench, you're in the hadopelagic zone. Now, obviously, not every area of the ocean has a hadopelagic, only areas with a trench. Also, you have to understand that organisms that live in the bathypelagic and abyssopelagic are going to act differently than the organisms in the mesopelagic and epipelagic. For instance, mesopelagic fish are close enough to the surface that they may actually go to the surface at night. Whereas bathypelagic and abyssopelagic will never go to the surface. It's too far. We're talking miles and miles and miles of trip. Also, organisms in the epipelagic eat phytoplankton, whereas organisms everywhere else in all these 4 other zones won't eat phytoplankton because there's not enough light or no light in those areas for photosynthesis. And so these are just some of the differentiations that you have to that create the differences between the organisms that live inside these zones. Marine scientists are just as lazy as high school seniors in June, so the idea is that no one really wanted to memorize 5 regions, and in fact, unless you're talking about 1 or 2 discrete things, you can just get away with saying the shallow ocean and the deep. So when we can get away with saying it, we're not going to divide up the ocean into 5 zones, we're going to divide the ocean up into 2. Just like marine scientists, there are 2 zones of the ocean: the photic zone, which, if you're looking carefully enough, is basically the epipelagic zone. It's the area where there's enough light for photosynthesis. And the aphotic zone, which is a generalized region, anything deeper than that top 2%, anything deeper than the photic zone. You might hear me say the photic zone is the shallow ocean and the aphotic zone is the deep ocean. That's fine too. 99% of the time, we're going to be talking about organisms that live in the photic as opposed to the aphotic. And then once in a while, I'll have to explain, okay, so these are adaptations of organisms that live in the epipelagic versus the mesopelagic, and so on. So now that we have the basic idea of the different zones of the pelagic ocean, let's go into really briefly the 3 things that we're going to be talking about when it comes to organisms. There's a couple fish in the sea, a few of them, and as a result, it's not going to be really easy to start going fish by fish by fish and talking about each fish individually. All organisms in the ocean, fish and otherwise, are actually going to do really 3 things, and they're going to be specially adapted to do these 3 things in the ocean. The first is something that you kind of just take for granted, which is that one of the things that all organisms in the pelagic ocean need to do is stay above the ocean floor. A lot of people say or think that fish swim and that's the way they stay above the ocean floor. But you swim and that's how you stay above the ocean floor. And if you swam to stay above the ocean floor, you would eventually exhaust yourself, sink to the bottom, and die. Fish are the same way. They're not going to swim all the time. They're not swimming to stay above the ocean floor. Organisms in the pelagic ocean need to have special adaptations that allow them to float. Organisms don't float by themselves. You don't float. If people floated, drowning wouldn't be a thing. That's a fact. As a result, all organisms in the pelagic ocean need to have an adaptation that helps them stay above the ocean floor so that when they eventually stop swimming, they don't sink to the bottom and die. The next thing all organisms need to do is this: either find food or avoid being eaten. One of my favorite theories about the ocean is called the ubiquity of prey theory. It states that there is no organism in the ocean that isn't eaten by an organism in the ocean and doesn't itself eat another organism in the ocean. In other words, the ocean is basically a horrible hellscape of everyone hunting and eating everyone all the time. The reason fish weren't born with vocal cords is because if they would scream constantly, blood-curdling screams for their lives, and it'd be terribly, terribly annoying. So, all organisms in the ocean need to be adapted to both find food and, just like this little scarlet shrimp, avoid becoming prey. If you find food and avoid becoming prey, and if you can stop swimming long enough to get a rest and not sink to the bottom and die, you need to do this third thing. This third thing is mating. All organisms in the ocean need to mate, need to sexually reproduce, or asexually reproduce, depending on what organisms we're talking about. And that's what I'm actually showing you here. This is an anglerfish. This is the fish from Finding Nemo with a little lantern on it. And this is a female anglerfish. You can tell that aside from just the fact that she's generally attractive, because the male is actually permanently attached to her down here. This is the male. This is obviously a deep sea fish, and the reason the male is attached to this female is because in the deep, there's not a lot of organisms, and the chances of you finding another organism are very slim. The chances of you finding another organism that's the same species of you is even slimmer. The chances of you finding another organism that's the same species of you and it's the opposite sex as you is even slimmer still. And the chances of you finding another organism that's the same species of you, that's the opposite sex of you, that's actually of age to mate with you is even slimmer still. And last but not least, the odds of you being a deep sea organism that is going to find another organism that's the same species of you, that's the opposite sex of you, that's able to mate and willing to mate with you, that's even slimmer still. As a result, you can't rely always in the deep and for that matter in the surface as well to just run across another fish and start having sex with them. So organisms have to be specially adapted to be able to successfully mate in the pelagic ocean. Depending on whether fish live in the photic or deep, they'll do these three things: finding mates, staying above the ocean floor, and finding food and avoiding becoming predators differently. And that's what we're going to spend the next 3 lessons actually talking about. So that concludes this lesson. We started talking about the 5 zones of the pelagic ocean: the epi, meso, bathy, abysso, and hadopelagic. Epi, enough light for photosynthesis. Meso, light but not enough for photosynthesis. Bathy and abysso, and for that matter hado, are all completely dark, but they go in that order of depth. Hado is inside an ocean trench. Another name for the epipelagic is the photic zone, and then anything below the photic zone would be the aphotic zone. And no matter what organism you are, whether you live in the photic, aphotic, epi, meso, bathy, abysso, or hadopelagic zone, you have to do 3 things: stay above the ocean floor, find food and avoid becoming prey, and last, successfully find mates. And that's the 3 things that we're going to be talking about coming up in the next lesson. So thanks very much for listening, and I will talk to you then.